right? So you have the unusual, could happen, not likely. But the outlier is that's impossible. How did that happen, right? So the forecast for tomorrow is that it's going to be 300 degrees Fahrenheit. That's not physically possible, and like we're not forecasting that. We're not. Let's just put it this way: if the forecast, if somebody determined that tomorrow it's going to be 300 degrees Fahrenheit out, they're not putting that in the 10 o'clock news or 11 o'clock news. They're putting that out on the emergency alert system. Like dig a hole and bury yourself. Like that, it's impossible. It's not going to happen. That's an outlier. Now, outliers can happen in a couple of ways. One way is that somebody made a mistake. It's December. They said it's going to be 300 degrees out. They made a mistake. What was the mistake? An extra zero. It was a typo. Right? They meant to say 30 degrees. They accidentally put a zero at the end and it became 300. Or they said 300. They screwed up the font on the last zero. It's supposed to be a superscript, making it a degree symbol, and somehow it became a big zero. And then, of course, mass panic in the whole world. Looting and riots and things. The other possibility is that the impossible, I guess, is happening, but not because it's supposed to, just because something occurred that caused the impossible to happen. All right, I call it the Billy Madison effect. I don't know how many people, I mean, the older I get, the less people can relate to the movies that I've seen and the ones that I've loved. But that's the one where the 30-something-year-old person goes back to elementary school. So it's a great movie. Homework, watch Billy Madison. It's actually a pretty dated movie, so some of the humor is like 90s humor, but sometimes we need a little 90s, and that's understandable. Uh, but that's a case where if I were collecting data, I'd go into a classroom and I would say, all right, I want the ages of all the students in here. So I get 7, 8, 7, 8, 7, 8, 28. Where did that 28 come from? Well, it was either a mistake or you have the impossible occurring. All right, that's the outlier. Now, it's a question of what do we do with that outlier? Do we keep it? Do we get rid of it? If there's a legitimate reason for that outlier to be there, then keep it. If the impossible occurred, keep it. If it's a mistake, get rid of it. All right. So this data set could be, I don't know, it could be the ages of people, the ages of students in an aftercare program. Like a preschool aftercare. Like my kid used to go to one of those. They'd have like after the elementary school gets out, they go to the aftercare. The kids pick them up. The parents pick them up at like 5 o'clock. So you take the ages of all the students in the room, but accidentally accounted for an adult. All right, well, that shouldn't be there. Get rid of it. All right. Or somebody forgot to hit tab to create space between the 4 and the 2. That's supposed to be a 4-year-old and a 2-year-old. All right. If that's the case, make the adjustment, make the correction. But if you can't guarantee that was a mistake, then get rid of the 42. All right. So there's ways of handling it, but there's also a possibility that it's not an outlier. It's definitely unusual in commonplace thinking. You look at it, you say that 42 shouldn't be there, but we have not mathematically justified that. So let's do that. So the first thing we do is we find the median, and the numbers are all in order, so we're good. The middle number, I'm doing my finger counting business here, but the middle number is 7, right? All right, so we're good there. Now, we have some notation that makes up our outlier formula. It's some funky notation, the LQ, the IQR, the UQ. The LQ is the quarter waypoint. The UQ is the 3/4 waypoint. half of a half is a quarter. So what we're going to do is look at the values that are to the left of the median. So ignoring the median, that's the middle. Find the middle of the lower half of data, lower numeric. So the left side. Count to the middle. Here we have two middle numbers. So I'll use my crossing out technique, but you're counting to the middle, so basically you're finding the median again. So these two guys would make up the median of that new set of data. Halfway between 4 and 5. You could set it up. You do 4 plus 5 over 2, but halfway between 4 and 5 is 4.5. That's going to be our LQ. It stands for lower quartile, but we're going to formally discuss that concept when we talk about box plots. So right now you just write LQ, but if you want to make a note that it's the lower quartile, you could do that too. And also, this is a common thing that I'm going to say throughout the semester when I show you how to do something by hand. There will be a way in which we can do all this stuff on the calculator without doing any of this work. So, but this is one of those things where in order to really feel out and understand the concept, doing it at least once by hand, it does make sense. All right, IMO. So 8 and 42, 9 and 10, okay, so we're counting into the middle, so cancel the 8 with 42. The 9 with the 10 would be the two values that make up the upper quartile, which would be halfway between 9 and 10, would be 9.5. And that would be our UQ, also known as upper quartile. All right, so we have some numbers. We can do some stuff with those numbers. Though actually, the one number that we don't really need is the median. We just needed the median to identify the location of the median so we could figure out the other stuff. IQR is UQ minus LQ. Stands for interquartile range. But again, when we get to box plots, which would be 2.4 in your textbooks, or your OpenStax textbooks, we'll discuss that in more detail. So right now, let's get the process down. It's going to be 9.5 minus 4.5, which is 5. All right, so I'm going to rewrite my rule. This is one of the few connections to college algebra, maybe pre-calc a little bit. This is known as interval notation. And so this is giving us an interval of values. And that interval of values is going to help us determine whether or not there are any outliers. Right? But for now, we're just going to do the calculations within each component of the interval. The comma separating the lower end from the upper. So LQ we identified as 4.5. So 4.5 minus 1.5 times IQR, which is 5, comma UQ, which is 9.5, plus 1.5 times 5. You can crunch out the calculations all in one shot, or you could do it a piece at a time. I'll do it a piece at a time. 1.5 times 5 is 7.5. Purple is next on the list. So we're looking at -3 on the low bound and 17 on the upper bound. All right, so that gives us an interval. Oh, I can scroll up. So all of those calculations will give us an interval. And like I said, calculator tricks, they're starting next week, and they're coming early and often. You'll either love them or hate them. The quicker you get to know your calculator, the easier things will be. But that last handout that I gave you, just hang on to that till next week, and I'll talk you through that. That's a getting to know your calculator activity. But that's going to help. But there's no point doing anything with it now if you don't have a calculator. This interval is a very important interval. This is the interval of non-outliers. All right. So it's not an outlier if it is in this interval. Right. The brackets, those they call any kind of parentheses or brackets or anything like that fencing, like the fencing of an expression. If it's in brackets, it means it's inclusive. So that means that the -3 and the 17 are included in the set of values that are not outliers. So -3 is not an outlier, although common sense tells us that it would be. Because if I give you context in that situation, I tell you you're talking about ages of kids in a daycare, and I tell you one of them's -3 years old, and you say, oh, what are you, a wise ass? You know, so 17, okay, I suppose there might be a 17-year-old in daycare. Might not be the most mature person in the world. That'd be weird if a kid is driving himself to daycare. Yeah, but it's possible, I guess, somewhere. But looking back at the original data set, we're going to identify any value that does not fall in that interval. The only value that does not fall in that interval is 42. So therefore, 3 dots in the form of a triangle stands for therefore, but you can write the word therefore if you want. All right. I just err on the side of not having to write words because odds are I'm going to screw it up at some point, even though I was the 4th grade spelling bee champion of Dutchess County. 42 is an outlier. But really, what most people get from that is that I peaked in 4th grade in terms of my spelling and grammar. All right, so common sense told us that it was an outlier, but only when I gave you a little context to the data. If I just gave you numbers, I say, are any of these numbers an outlier? I say, I don't know. They're just numbers. But then I tell you the age of the kids in a daycare, then, okay, yeah, 42 is an outlier. Right? If I tell you that it's gas mileage, okay, now anything lower, like all these values, you'd be like, well, those can't be, miles per gallon, at least not on any vehicle I would want to have. So can an entire data set be outliers? Oh yeah, it's possible. You can make a whole ton of mistakes. Right? But at that point, we wouldn't call it an outlier, we'd call it a crap study. All right? So just a little bit to think about. When we start talking about things like the paper, I can leave this on. You're going to want to, you may or may not opt in, right? If you want to take the test, you take the test. A lot of people opt to take the test because it's a standalone one-day engagement, right? The paper involves revisions, collecting data, coming up with ideas, things like that. But there's something for everyone there, so it kind of works. But if you think, because some people have already decided, that you're leaning towards writing, or doing the research paper, the project, then you probably want to start thinking about what kind of data you'd like to collect. Right? Quantifiable data, so any data that's numerical based, is something that we can work with. but it should be something that you could draw a conclusion from. Right? So some kind of context that has a numerical association and something that would be easy to collect, because you might want to change the world with your study. The problem is if you can't access that data, then it's like, well, not only are you not going to change the world, but you're going to fail. So like strike 1, 2, and possibly 3. But yeah, keep an eye on things that might be considered to be outliers. All right, so something like this, this technique is pretty important for you. And then next class, when I start talking about how to do this on the calculator, you'll see just how easy it is to identify outliers without having to go through this process. All right.